Beneath 40 meters of dark, shifting seawater, engineers are preparing to sink concrete giants, each one longer than 2 football fields and weighing more than 70,000 tons. They must align them to within millimeters, and they must do it before time runs out. This is the $7.5 billion race to sink Europe's deepest tunnel. Stretching between Denmark and Germany, this 18-kilometer immersed tunnel will carry both cars and trains, shrinking borders and changing how Northern Europe moves. But the challenge isn't simply construction. It's a battle of precision against nature. In 2025, the Fehmarnbelt project entered its most critical phase. The first full-scale tunnel elements were ready for immersion, but delays in the specialized machinery built to lower them threatened to derail everything. When complete, the link will cut a slow ferry crossing into a 7-minute train ride or a 10-minute drive, a megastructure designed with atomic-level precision to survive one of Europe's harshest marine environments. But before this tunnel could begin, the idea itself had to survive years of doubt. In 2008, a quiet signature between Denmark and Germany set one of the most ambitious infrastructure plans in motion. On paper, the Fehmarnbelt Fixed Link was simple: connect 2 nations divided by the sea. But the plan wasn't for a bridge. It was for a tunnel. One built not through rock, but through water. To many, it sounded absurd. The Baltic's currents were unpredictable, the sediment unstable, and the budget staggering. Yet both nations knew the cost of doing nothing. The ferries between Rodbyhavn and Puttgarden had become a choke point for Europe's trade, carrying millions of passengers and hundreds of thousands of trucks each year, but never fast enough to meet demand. If the plan worked, the 4.5-hour Copenhagen to Hamburg journey would shrink to barely 2.5. Trains would fly through the seabed in 7 minutes. Cars would cross in 10. The tunnel would complete a key piece of the EU's 10T corridor, an unbroken chain of rail and road stretching from Scandinavia to Sicily. But this was more than transport. It was a declaration. Europe could still build the impossible. On the southern coast of Denmark, near the quiet town of Rodbyhavn, a new world began to rise. What had been farmland and sand dunes turned into one of Europe's largest industrial sites. A purpose-built factory created solely to manufacture tunnel sections the size of city blocks. 6 colossal casting halls lined the waterfront, each producing the reinforced concrete segments that will form the backbone of the tunnel. Massive steel molds are filled with a specially formulated concrete mix designed to withstand decades under saltwater pressure. Each pour must cure for weeks before the next can begin. The process resembles shipbuilding more than civil construction. Every standard element measures 217 meters in length, built from 9 separate segments, and weighs around 73,500 tons. 10 additional service elements, shorter but taller, will house ventilation ducts, safety corridors, and technical rooms. Altogether, 89 pieces will form the completed tunnel, a structure long enough to stretch from Manhattan to the Bronx. Each element is sealed at both ends by steel bulkheads, turning it into a floating vessel. Inside, ballast tanks work like lungs, breathing in or expelling seawater to control buoyancy. Once an element is sealed, it can float freely, waiting for the moment it's towed out and lowered beneath the waves. But before that can happen, the ocean floor itself must be sculpted. Out on the Baltic, an entire fleet of custom vessels has been at work since 2020. Dredgers such as Magner, Manta, and Vox Amalia carve a channel nearly 40 meters deep and up to 70 meters wide, deep enough to fit a 12-story building. More than 15 million cubic meters of clay and sand have been removed, enough to fill 6,000 Olympic swimming pools. The work demands millimeter accuracy. Even a small ridge or uneven slope could cause a tunnel element to tilt, twist, or jam. To create a perfect foundation, a pontoon named Maya lays down a gravel bed guided by lasers and GPS sensors, so precise they can detect errors smaller than the width of a coin. Above the surface, another engineering miracle waits. To lower the tunnel segments into place, engineers designed 2 one-of-a-kind immersion pontoons, IVY-1 and IVY-2. Each functions as a floating crane the length of a football field. Steel winches and thick cable slings hold the tunnel section below, while computer-controlled hydraulics compensate for wind, current, and waves. guided by RTK-based GPS, accurate to within millimeters. These pontoons will gently lower each 73,000-ton block into the trench. Once the section settles on its gravel bed, the pin and catch system locks it to the previous one. Then the NP460 spreader pontoon secures the sides with gravel, while Vismar covers the top with protective rock layers. Piece by piece, the tunnel will stretch across the Baltic until Denmark and Germany meet in the middle, an underwater handshake between nations. By early 2025, the world watched as the first 2 tunnel elements floated from the casting basin. Nearly 1 million cubic meters of water were pumped in to lift them. The event was hailed as the start of the final phase, but then everything stopped. The IVY pontoons weren't ready. Software tests lagged, certification was delayed, and the critical immersion window began to close. By midsummer, internal reports warned of a possible 18-month delay, threatening the official 2029 opening date. For a project of this size, time isn't just money. Once autumn storms arrive, the operation pauses until spring. Every day lost pushes the schedule further. Every delay multiplies the cost. On paper, the engineering was flawless. In reality, the ocean refused to cooperate. The Fehmarnbelt Link isn't just concrete and steel. Its political will cast into physical form. Funded mainly by Denmark through the state-owned Fehmarn AS and supported by hundreds of millions in EU grants, it stands as a flagship for Europe's green transport revolution. If completed on schedule, it will shift freight from roads to electrified rail, cut emissions, and boost trade from Scandinavia to southern Europe. But if it slips, it could become a symbol of European overreach. Another grand vision stalled by bureaucracy. Environmental groups have fought it for over a decade, warning of harm to marine life, especially the Baltic's harbor porpoises. Construction began only after Germany's highest administrative court dismissed the final lawsuits in 2020. Even now, scientists monitor underwater noise and ecosystem impact throughout the work. For the engineers on site, those debates fade into background noise. Their reality is the ticking clock, the aging equipment, the narrowing weather window, and the pressure to deliver something that's never been done before. Amid the tension, one success story has already changed Denmark's shoreline. Instead of discarding the dredged material, engineers repurposed it to expand the coast. 15 million cubic meters of sand have formed 300 hectares of new wetlands, dunes, and recreation zones. The coastline now extends 500 meters farther into the sea, protecting Rodbyhavn and creating new habitats for seabirds and marine life. What began as a construction necessity has become an environmental restoration on a scale few expected. The town itself has transformed. Where ferries once idled, new homes, workshops, and cafes have sprung up. Thousands of workers from across Europe now call Rodbyhavn home. For them, this is more than a project. It's a new beginning. Beneath the cranes and concrete lies a human story of endurance. The Fehmarnbelt Link has become a test of patience, skill, and belief in progress itself. And as the tunnel elements wait in the harbor, their steel skins glowing in the Baltic sun, one question hangs over them all. When will the sinking begin? Until those giants vanish beneath the waves, the world's most ambitious underwater tunnel remains a promise, and a race against time that Europe cannot afford to lose. By the end of 2025, 2 completed tunnel elements floated silently in Rodbyhavn's harbor. Just months earlier, their launch was celebrated as proof that Europe could still deliver on grand visions. Now they sat motionless, waiting for the only resource beyond human control: time. Inside the control cabins, engineers worked through sleepless nights, calibrating sensors, testing hydraulic systems, and running simulations. The IVY pontoons, designed to sink the elements, had to perform perfectly. A single failure could destroy years of work. Digital maps of the seabed filled the monitors in blue and green lines. Crews rehearsed every step. Lift the element, tow it to the trench, lower it 40 meters, align within millimeters, and lock it into place. The cables would strain under 73,000 tons of tension. One misread sensor or hydraulic lag, and the entire section could twist or crack. Each element costs tens of millions, but the real risk lies in precision. If even one segment lands slightly off, the rest of the tunnel could be thrown out of alignment. As summer fades, the wind over the Fehmarnbelt grows colder and more violent. The storms roll in, the waves rise, and the narrow window for immersion begins to close. Once the sea turns rough, the pontoons must wait until spring. Each passing week burns money. The 2029 target drifts toward the next decade. What was meant to be a showcase of efficiency is now under scrutiny. In Brussels and Copenhagen, officials trade cautious optimism with concern. Can Europe still build at this scale without losing momentum? On site, no one talks about politics. The workers care about the same thing every morning. Can we do it today? Can the technology finally beat the sea? By late autumn, the IVY pontoons stand ready. Massive steel decks crowded with winches, cables, and control towers. Each can bear more weight than the Eiffel Tower. Their hydraulic systems constantly adjust to the rhythm of the waves, maintaining perfect balance. Every immersion will play out like a slow-motion ballet. A finished tunnel section will be towed from the harbor, suspended between the pontoons. Using real-time sonar, lasers, and GPS, operators will lower it meter by meter until it hovers above the seabed. Then it locks to the previous section. Ballast tanks flood, and the piece settles permanently into the trench. It's a sequence that must happen 89 times, and each one is riskier than the last. A single operation can take 2 days, but one storm can halt progress for weeks. The Fehmarnbelt Link is far more than a shortcut. It's a shift in Europe's geography. Once complete, freight trains will move from Stockholm to Munich without a single ferry. Cars will drive from Copenhagen to Hamburg as if the sea between them never existed. Together with the Øresund and Great Belt bridges, the tunnel will complete a chain of megastructures linking Scandinavia with Central Europe, one of the most connected regions on Earth. For Denmark, it's a national triumph. For the EU, a symbol of what integration can still achieve. And for engineers worldwide, it will stand as proof that precision and ambition can coexist at an unprecedented scale. Yet even success carries its shadow. Environmental groups still monitor every noise and vibration beneath the waves. The project has become a test not only of technology, but of conscience. Can progress reshape nature without erasing it? Now, optimism is creeping back into Rødbyhavn. The IVY pontoons are passing their final tests. Hydraulic systems are stable. Sensors are calibrated. If weather holds, the first immersion could take place within months. On the docks, welders seal final plates. Engineers pace the decks, their breath clouding in the cold air. The sun hangs low over the Baltic, turning the water to liquid silver. Everyone knows that once the first element sinks beneath the waves, it will mark more than progress. It will mark history. Because once that section locks into place, the Fehmarnbelt Link will no longer be a plan on paper, but a reality beneath the sea. Soon, the tunnel will vanish from view, silent, sealed, and unstoppable. But as winter sets in and storms gather strength, one question still hangs over Europe. Can they sink these 73,000-ton giants before the weather, the politics, or time itself sinks them first? Because when you're building the deepest immersed tunnel on Earth, the race isn't against rivals, it's against nature itself.